Okay, today we're going to talk about trigonometry. So trigonometry is kind of similar to the Pythagorean theorem. It deals with right triangles and stuff like that. And it's talking about basically it brings angles back into the equation. So Pythagorean theorem is all about just the sides. Trigonometry is about angles and how if you take one of the special relationships between the angles of a triangle, you can get a certain kind of ratio. And there are three core ratios that we talk about in trigonometry, and that is sine, cosine, which we just call cos, and tangent. Okay? And then there are three more sub ratios that are just the reciprocals of those. And that would be well, I'll get to those in a second. Now, when I'm talking about ratios, I'm talking about the ratios between two sides on a triangle. So if I have sine, I'm talking about the opposites. Well, let's look at a triangle. So let's say I have a triangle here. I have a right triangle right here. Okay? And let's say I'm looking at this angle right here. We'll call it theta. Okay, that's what that little O with a little line through it's called. The zero with the line through it, that's called theta. Okay? Now, if I'm looking at this angle, which side would be opposite this angle? This would be the opposite, right? This side would be the adjacent. And then again, the side that's opposite at the right angle is what we call the hypotenuse. Okay? Now, opposite and adjacent, they could flip around depending on if I'm talking about this angle or this angle, right? But basically, when we talk about a specific angle, then we're talking about the lines that go to that angle. Okay? And it's all about opposite, adjacent, and hypotenuse. So with sine, the ratio that is equivalent to sine is opposite and hypotenuse. So it'll be opposite over hypotenuse. So it would be written like this: opposite side over the hypotenuse. Okay? With cosine, it's the adjacent side over the hypotenuse. So adjacent over the hypotenuse. And with tangent, again, this is all using the same angle. And I'll talk about how that works here in a second. But really today we're just going to be talking about these ratios. So with tangent, it's the opposite over adjacent. And now if you notice, if you read this straight down, the term that people use to remember these ratios is SOHCAHTOA. SOHCAHTOA. Okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? Now, there's also the reciprocals of these. So the opposite of sine is what we call cosecant, or CSC. Okay, and that's just hypotenuse over opposite. Okay, so it's reciprocal, right? The opposite of secant, or of cosine, is secant. Okay, and that would be hypotenuse over adjacent. And then we have the cotangent, which is adjacent over the opposite. Okay? Now, that's a whole lot of gibberish that you don't understand right now. That's fine. Okay? That's the kind of stuff, this is the stuff you need to know and understand in order to do the next part, okay? Now, what we're going to be doing today is it's going to give me one of these relationships. So it's going to say, I know that the cosine of theta is equal to 4 over 5. So remember, cosine is the adjacent side or the hypotenuse. So that means if the cosine of theta is equal to 4 over 5, if I were to draw my right triangle, so right here, here's my theta, okay? And I know that the cosine is 4 over 5. That means that the adjacent side, so this side has to be 4, and the hypotenuse side has to be 5. Okay? Now, it wants me to find the sine and tangent. Now, the one problem here I have is that in order to find the sine and the tangent, I need to know all three sides. I don't know the opposite side, but I do know the Pythagorean theorem, right? I can use the Pythagorean theorem to figure out the opposite side. We'll call it x for now. Okay? If I want to figure out that, then again, I just do the x squared plus 4 squared equals 5 squared. Gives me x squared plus 20 equals 25. Right? No, 16. That makes more sense. I'm like, I know it should be 3. So you'd minus the 16, you'd get x squared equals 9. And then you square root. X is going to equal 3. Okay, so that means the opposite is going to equal 3. So now, if it wants me to find the sine of theta and the tangent of theta, so sine of theta, that is opposite. So opposite over hypotenuse. So 3 over 5. Tangent of theta is opposite over adjacent. So 3 over 4. And that's all it wants me to do today. Just figure out those ratios, right? So let's look at another one. This one's a little trickier. So find the cosecant of theta and the sine of theta if cotangent is 6 times the square root of 3 all over 6. So let's set this up first. Again, I'm going to have to use the Pythagorean theorem. And let's see what I know. So cotangent is the reciprocal of tangent, so it is actually adjacent over opposite. So if this is the cotangent, that means that the adjacent, so again, let's say this is theta. So the adjacent would be 6 square root of 3, and the opposite would be 6. I need to figure out the hypotenuse. Okay? So to set that up, I would do 6 squared plus 6 times the square root of 3 squared equals x squared. Alright? Now 6 squared is 36. 6 be 36 times 3, right? 6. And then, hold on. Calculator is not cooperating. No. Dumb calculator. Okay, yeah. 36 times 3, which would be 108. So I would get plus 108 is equal to x squared. Okay, combine those. 108 plus 36 is going to be 144 equals x squared. And then square root, you would get 12. Okay, so that means that this longest side, or the hypotenuse, is going to be equal to 12. So to set up the rest of these, cosecant, well, let's do sine first. So sine of theta is going to equal the opposite over hypotenuse. So 6 over 12, which does simplify down to 1 over 2. Okay, so there's the sine of theta. Now, cosecant of theta is the reciprocal of that. So hypotenuse over opposite, which would simplify down to 2. Okay, and that would be your answers. Not too tough, right? Let's look at another one. Let's look at one of these. Back to our original one. So this one, sine of theta, wants me to find sine and tangent, and it gives me the cosine is 1 over 2. So again, we're going to set up our triangle just to make sure that we understand what we're talking about. So here's my theta, and it gives me a cosine. Cosine is 1 over 2. And again, cosine is adjacent over hypotenuse, right? Adjacent over hypotenuse. So 1 and 2. Okay. Now it wants me to find basically what this other side is here, right? So again, to set that up, I know it's got to be 1, but set it up, it would be x squared. We'll call it x squared plus 1 squared equals 2 squared. Okay, we square all that, we'd get x squared plus 1 squared. Actually, it wouldn't be 1. Or it'd be 1, sorry. 1 plus equals 4. Minus 1, we get x squared equals 3. So that means that x, or my opposite side, has to equal the square root of 3. Okay? Now to find sine of theta, that is opposite over hypotenuse. So the square root of 3 over 2. Find the tangent of theta. It is the opposite over the adjacent. So the square root of 3 over 1, or just the square root of 3. And that would be your answers. Not too tough, right? Again, once you have the SOHCAHTOA down, it's basically just use the Pythagorean theorem to find whatever side is not given to you, and then you just set it up with the appropriate ratio. And that's all you're doing today. Again, this will make more sense when we get to more. This is just identifying the ratios. We use these to find lengths and distances and stuff like that in a lot more detail than you could with just the Pythagorean theorem.